If you stop screen sharing, there's a record
I think
button on like the bottom of the options.
exactly. It is there, but once you screen share, it's not anymore, isn't it? No,
Yeah, but it'll still be recording once you screen share.
yes, exactly. Stop record. Yeah, it is recording right now. Good. Okay. It takes some time to get used to it, huh? Okay. So expectations. I wrote down a little bit about what I expect from you. So I would like you to have camera on, and I see that most of you do have that, because I want to see a little bit of discussion. Isn't it? Then it would be good to use chat from time to time when I ask you questions, maybe, and also use microphone when you ask questions. Of course, that's kind of obvious. And several times I will ask you how we are doing. Did you manage to repeat after me? It used to be when we were meeting in a classroom that I would go around the classroom and see where people are at. I mean, whether they're coding, whether the code works. Usually there were lots of errors. And I was able to look at somebody else's computer and help to resolve the issue. Okay, so that's how we did it in the past. So um, I was able to help. Now, I don't know how this is going to work. I'm scared of that because I might ask you to share the screen so that everybody is going to see, that I'm going to see, and I guess everybody else will see. And probably will not be able to check how everybody is doing, but maybe at least a few times you might be asked to share, to show your work or to share the screen, just to be a little bit more lively. Okay, this is not going to count to your grade. Okay, but I think it's not a good idea that I share the screen all the time, but it's sometimes a good idea that some of you show what you managed to do or how does your code work. Okay, is this acceptable? You know how to share the screen? I will stop the screen sharing and then I will allow you to share the screen. So you should be good to go. Right now you can't, I think, because I'm sharing. But once I stop sharing, then you should be able to share. Okay, and I added the transcript closed captions on, so I think you can also read on the bottom, doesn't it? If your wireless doesn't work so well, then you should be able to read. Okay, this is all about the introduction. So now we can go to this part A about installation. If you want to follow a course by downloading this PDF online, you can click on part 1 and you can follow yourself on the lecture notes. I prepared the same lecture notes on iPad, which is here. And let me try to show you this. So this is my iPad. Do you see this iPad setting up computing environment? Do you see that? You do. Okay. So we're going to go through this. So I'm using Mac. How many of you use Mac or Linux or what? What do you use? Mac? Mac, yeah, Mac. So what about Linux? Does somebody use Linux? You do? So
I use both.
Both, okay. So I will demonstrate things on Mac. And people who usually use Linux can kind of translate because there are relatively simple things for people who are used to Linux, because you have to install everything, well, most of the things yourself when you use Linux anyway. So I'm usually not afraid of people with Linux background, but with Windows might be a problem because for example, installing C++ or Fortran compiler on Windows, I don't know how to do it because I don't even know which compiler to choose. So in this case, you might be well, left on your own a little bit, or harder to follow. So how many of you use Windows only? Do we have a Windows user?
Yeah, me.
Okay, so there are some. Oh, okay. Yeah, so I mean, you could still, it's still easy to install Python and those Python NumPy, Skype, and Matplotlib things. Okay, so this is going to be okay. So there at least maybe 70% of the course you can still follow. But when it comes to improving, speeding up Python, then I will not be able to help you on Windows. You might be able to find resources online, how to do it, how to translate for Windows, but I don't know how to do it because I don't even have Windows computer to play with it. Okay, so unfortunately, these things are unfortunately not so easy to get things working on every platform. It's not completely straightforward. Okay, but most of the course you can still follow because it's going to be mostly in Python, and Python is easy to install everywhere. Okay, acceptable?
Okay.
Okay. So in the past, I provided something which is called virtual machine, which has light this light Linux Ubuntu installed. So you could use this virtual machine on Windows, for example. Now I didn't set up this for this year. I think it's 2 years old thing. And if it's absolutely essential, if somebody is really struggling with getting things done on Windows, I might go back and update this virtual machine and make sure that it still works. Okay, it's at least 2 years old, and things are changing so much that 2 years old virtual machine probably it's not good enough. But again, this is a backup scenario. If somebody is really struggling on Windows and needs this, I will do it. But I didn't prepare yet. So let me know. Okay, so now essential software. We're here. What are we going to use? Python, in particular with libraries, NumPy, SkyPy, Matplotlib. Okay, and we're going to use so-called Anaconda distribution. Okay, so this Anaconda distribution is easy to install for every platform, including Linux, Windows, and Mac. You basically just click and you get all this easy installation. We're going to go through this installation process today. And this part, straightforward for everybody. Now, C++ compiler, such as GCC, it doesn't need to be GCC, but it can be any other C++ compiler, would be really, really good to have. Why? Because then we can speed up Python. Okay. Right now I'm using I'm going to demonstrate this with PyBind 11. There used to be something which is called Weave. I don't know if any of you knows about Weave. It's something that we could use. We could kind of inline some C++ code in Python to speed it up. But it turns out that they discontinued this in Python 3. And we're going to use Python 3. I used to use Python 2 in the past, but now since Python 2 is obsolete with this year, 2020, actually last year, it was made obsolete. So we need to use Python 3 now. And it turns out that Weave is not supported in Python 3. So I switched now to PyBind 11, and it's a pretty powerful tool, and requires some type of C++ compiler. Again, this part might not be completely essential. Maybe should be put under recommended software, but it's very good to have. Then, of course, essentially is a text editor. It can be any text editor you normally use. I use Emacs, and basically on Mac I use something which is called Aquamax. But any other text editor is fine. So my text editor is this one, Aquamax. Oops. Okay. And with this I code, isn't it? Show my yeah. I'm very used to Emacs. Now, for you, it might be better to use Spider. This is something that comes with Anaconda, and it's kind of part of Anaconda environment. And if you're not used to Emacs from before, Spider might be a better choice. And as far as I know, everything can be done with Spider as well. But in the past, we used to use VI. Does anybody know what is VI? VI? No?
I'm using
Yes.
VI.
You are. Okay, so there are some people from that know basics. So yeah, we used to use VI in the past, but if you're familiar with this and if you like it, then of course it should be okay. Then finally, make. Make is something that is very basic and on Linux is definitely installed, and you must have it. On Mac, we will show how to enable it. It's also usually exists, but usually not enabled. But on Windows, this must be a problem. This might be a problem. Make. I mean, because it's a way of combining things under Linux environment or Unix environment. Actually, Mac is also Unix. So if you have these tools, then probably you can follow more than 90% of the course. Now there are some other tools that I'm going to use just a little bit at the beginning. In particular, Fortran, and I'm going to use gfortran. Now this is just to show you how to speed up codes with so-called F2Py. Okay, I'm not going to actually we're not going to develop standalone codes in Fortran, of course. This is too old-fashioned for today's purpose. But nevertheless, it's good to know at least a little bit of this because there is so much legacy codes. In particular, all the linear algebra, for example, is all written in Fortran. And if you're doing physics, you will probably see some Fortran code from your colleagues from previous century. There is so much legacy code in Fortran that it's usually a good idea to at least know some very, very basics. Then BLAS and LAPACK libraries. Now, these are very low-level libraries that usually come pre-installed. For example, in Mac, you just need to select in Xcode that you want this command line tools, and they should be installed. On Linux, for example, this would be probably MKL library. And if you're used to Linux, you probably know what MKL library is because it has to be compiled with for your particular computer with your vendor. For example, if you have a Intel computer, then it has to be prepared by the Intel company, and it has to be this Intel library is called MKL library. Most likely, it's already installed on your computer if you've done any coding before. Now, BLAS and LAPACK has all these linear algebra, low-level linear algebra low-level linear algebra algorithms very, very efficiently coded. And it's fine-tuned for every computer. Now, if you don't have this installed, those higher level installation of Anaconda, for example, will probably install some less fast, some slower version of BLAS and LAPACK, and will still work, but it might be slower. So it's not disaster if you cannot install that, because your codes will probably still work, but might be slower. Now, finally, Openmp enabled C++ compiler. So we already said before C++ compiler, but your Mac already comes with C++ compiler. Okay, I'm sure C++ compiler is there, but most likely it's not Openmp enabled. So in other words, it doesn't support Openmp. Now, what is Openmp? It is a type of compiler that allows you to use several cores, not just one core, but several cores simultaneously. So your computer probably comes with at least 2 or probably 4 cores, okay? All new computers now come with 4 or 8 cores even. I think mine has 8 cores now. But your computer has probably 4 or at least 2. And most of modern software uses not just one core simultaneously, but more than one, okay? And with this Openmp, we can write our codes that will use more than one core, maybe all cores or any number of cores you want. Why is this a good idea? Well, because your codes will be faster. And I want to show you how to do that. Now, this is not essential because your codes will still run, okay? And will be 2-3 times slower. But I think it's a good idea to learn this because you might need this for your research later on, okay? So again, it would be nice to install, but it's not essential. And finally, I use usually GNU-plot for fast plotting. This is again not essential, but in several presentations, I will use GNU-plot. And if you know how to use some other plotting program, you can use that. But otherwise, it would be nice to install this GNU-plot yourself. Yeah, so this is pretty much all. Yeah, all the software that I intend to use. Hopefully, nothing else will pop up. And now I want to show you how to do this on Mac. Okay, how to step-by-step installation procedure on Mac. And I hope that Linux users will be able to translate this to you to how to do it on Linux. Is this more or less understandable up to now? Okay, so then let me go through step-by-step procedure on Mac. Okay. So if you have your Mac and you haven't coded before, most likely your Xcode might be stripped out of lots of tools for development. So basically, usually when you purchase a Mac, it doesn't have development tools enabled. Okay, therefore you would need to install Xcode if it's not installed yet, and you will need to enable so-called command line tools, isn't that? So I'm sure that command line tools are not enabled by default, or they're not installed by default if you don't do that yourself. But Xcode is most likely already installed. Okay, so you go to your Apple Store, Apple Store, I guess, Apple Store, and then you first find your Xcode, and most likely it's already installed. Okay, I would need to update, but I'm not going to update it now. But if you didn't install it yet, then you should install it, or maybe it's a good time to update. You can do this after the class. Actually, I'm just going to go through the procedure. I don't know if you're going to be able to do it in real time. You can try, but I'm not so sure. But I will give you as a homework to do this yourself afterwards, looking at the lecture. Okay. So the first stuff is installing Xcode, and And once this is done, then you have to enable so-called command line tools. Okay, command line tools. There is a way to do this through clicking. Okay, you click advanced, and then I think there is something which is called enable command line tools. But you can also do this in terminal. It's kind of easier to show in terminal, so therefore I decided to use terminal this year. Oops, how do I go to terminal here? Okay, yeah, now I have this closed caption here and I cannot show you the terminal. Okay, let me move this up. Here is my terminal. You see the terminal now, isn't it? It's too large. Okay. So in terminal, you will need to type Xcode select and then --print path. Now this just checks whether you have command line tools installed or not. Maybe you already have them. Okay. And if this path exists, then this is already done. You don't need to do anything. However, if this gives you an error or a warning or something, then you need to write Xcode select no, just one minus install like this. Okay, install double L. Okay, this should install the command line tools. Okay, so this part here, install command line tools. Okay, as I said, this is probably the simplest way to show rather than going through clicking, but you can also do it with clicking.
Can I ask a question?
Yeah.
Will you like upload these notes to the website after the class?
This is already uploaded.
Ah, okay, got it. Thank you.
So you go to this course 509. You go to introduction and part 1. Okay, it's all there. Yeah, let me go back. Okay, so let's say we have Xcode installed. Now, all these things, if you're using Linux, all these things that are in command line tools are already installed on your Linux, I'm pretty sure. Okay, because this is basic things like C++ and so on, which is definitely in Linux available already. Okay, so what is inside Xcode? You have C and C++ compiler, and this one is actually turns out it's Apple compiler, Apple C++ compiler, and it does not support Openmp, unfortunately. It's originally had the name CLang for Apple C compiler. But at least there is a C++ compiler, which is already a very good thing. Then this Xcode also has this BLAS and LAPACK libraries already, this low-level libraries. You don't need to install them anymore because they're already there. And we will use them later on by appending this command -framework accelerate to our command when we compile. Okay, so when you compile, or basically this is a linking instruction, it's you append -framework accelerate, and that already uses BLAS and LAPACK libraries. Okay, now BLAS and LAPACK, I'm pretty sure that on Linux it's already installed. And then finally, also the make command will exist once you install this command line tools. So, for example, if I type make, I get something. It says nothing to be done for all. So make is installed. It doesn't give you an error that the command doesn't exist. Okay, so all these things are now installed on Mac, and then we proceed to installing recommended software, not essential, but recommended software. Now, you might ask yourself, why don't I first explain how to install essential software like Python? And I start with those non-essential things first. And the reason for this is because we want to install low-level software first, such as GCC, such as C++ and GCC compiler, and then install Python on top of this. Okay, why? Because when you install Python, usually it checks your environment and it checks whether you have the best C++ installed, and then it will work faster if you have, let's say, GCC 10 with multi-core execution available. So therefore, it's a good idea to always install first the low-level languages, low-level things, such as GCC, okay? And then on top of this, you install the Python environment. Now, this is not essential in the sense that you can also install Python first and then GCC. And probably things will work, but will not be so efficient as it could be if you did it in proper order, okay? Because usually when you install higher level languages, higher level things like Python, they will look for your environment, they will check how your environment looks like, and then will try to use particular compiler that might be the best. Okay? So I'm going in this order in which I think it's better to go when you install yourself. So I said before that that the C++ that comes with on Mac is basically Apple CLang. It's not GNU C++ compiler, and unfortunately, it does not support Openmp. So this Openmp is the multi-core. It's something that allows multi-core instructions, which means that your code can run not just on one core, but on several cores at the same time. And that makes the code faster. Now, how do we avoid this issue? How do we use a compiler which is not CLang, but something else? Well, it turns out that you can also change CLang so that it will support Openmp. I've seen instructions on the internet how to do that. But it was so much hacking and so hard that I said that there is no way I can present this in this class, okay? A lot of hacking, not easy. So therefore, most of people say, do install rather different C++ compiler, which is the GNU compiler, rather than using CLang. So let me demonstrate first GCC -- version on my computer, and you will see that it's actually Apple CLang, okay? Apple CLang, which is not GNU compiler. And now if I try to do -f openmp, well, first it doesn't have any codes, but even if I had a code like manc.cc, it will say that CLang error unsupported option -f openmp. Okay, f openmp is something that compiles with this multi-core instructions, and so GCC itself does not support that. GCC that comes on Mac. Now, how do we enable then this f openmp? As I said, to do it for Mac compiler, Mac native compiler, it's extremely hard. You can find instructions, but I found this too hard. So the workaround is to install completely new GCC, which is the GNU GCC. And I will demonstrate you that I have this. The latest GNU GCC is GCC 10. So if I issue, instead of GCC, I issue GCC/10, I will see that this is actually Homebrew GCC, which is GNU software. Now, this GCC compiler is the one that you have on Linux. So if you have your Linux computer, I'm sure that this is exactly the compiler you have. Might not be 10, might be 9 or 8 version, okay? But all of them are fine. Version 8, version 7 even, it's fine. Version 10 is the latest, I think. And but on Mac, we don't have that by default. So therefore, we need to install that. Now, how do we do that? Well, installing a compiler is not easy. If you want to do it from source code, that's really hard, and we don't want to do that. However, there are very good um, systems or what is called environments which can install various applications, and one of them is called Homebrew. Okay, so Homebrew is like an app store, but it's a command line. Okay, so it's entire environment with which you can install GNU software. Okay, or many other software, a lot of other software. So the procedure is the following: we first install Homebrew, and then with the help of Homebrew, we can install several other packages. So this is called package manager, isn't it? It's package manager, just like App Store, but it's a command line. Okay, and mostly contains scientific software or GNU software. Now, how do we do that? Well, I posted here the command line thing that you can use, but you don't need to copy this from my presentation. Probably it's a better way. Oh, whoops, you didn't see the screen. Sorry, this is on my iPad, and I forgot to show you. So the point is that here in this presentation, you have this command line, how to install the Homebrew. Okay, you don't need to use this link here. You can just go to brew.sh in your browser. So brew.sh, and kind of slow right now. Okay, and then you can see here the command line. Okay, you just copy it. You copy this and then put into your command line, execute. Okay, that's all you need to do, and Homebrew is going to be installed. Okay, so this command line, of course, is identical to what we have in the presentation. Okay. It's going to take some time, but this is going to just install this package manager. Once you do that, you can start using the package manager. In particular, something which is called Brew Doctor, for example, will show you whether your current situation with package manager is okay. I mean, if you give it some error, then it will try to correct itself. Okay, but most likely when you install it, it should be fine. I have several warnings because well, I have lots of software installed, and some of this might not be in best shape. Okay, so Brew Doctor is something that helps you if you have issues. This is supposed to correct issues. And now we are going to start installing. So we're going to do brew install. Oops. Okay. So yeah, now we're gonna start installing, and we're gonna do brew install GCC without multi-lib. This is something they're gonna do. Okay, do you see this? Without multi-lib. And then we're gonna do we're gonna install also GNUplot. Okay, and what else? Yeah, that's it. These two. So GNUplot and GCC. Now installing GCC is going to take a lot of time. So when you do this, do it after the class, because this is a huge package. But this GCC is the GNU GCC, which has Openmp enabled. Now, there are issues here. In some newer versions of operating system, you might have issues with ownership of USR local. Okay, so it turns out that USR local in some of the newer operating systems might not be owned by somebody where you're allowed to write. Okay, and in this case, if you get if you get an error when you install Homebrew, you will need to issue this command: sudo change ownership -r who am I admin USR local. So the point is that your USR local on some of the versions of Mac might not be owned, you might not have permission to write. Okay, and in this case, you would need to issue this command. So only if you get error, otherwise you don't need to issue that. But if you get an error when you use Homebrew, then this might help you. Okay, but if you don't get an error, just forget about this command. Then another thing is you first, before you install anything, you should do Brew Search Gcc. Why search? Because search just shows you whether you have GCC installed. And of course, if you didn't have a Homebrew, you probably don't have GCC. But if you maybe used Homebrew before, then you probably search first, and then if you don't have it, you install. Okay. So for example, I used Homebrew before. Therefore, if I do Brew Search GCC, it will show me that GCC exists. Yeah. So you see, I have it. It says GCC is there. GCC version 10. Okay. But if you do this on your computer, it will probably say that, well, you don't have GCC. And then if you don't have GCC, then you will issue the command brew install GCC -- without multilib. Now I want to emphasize that this -- multilib is essential. Okay. Because this particular option adds Openmp support. Without that, you're going to have another GCC compiler which will not support Openmp. Okay, and the entire exercise would be useless. So this option, it turns out that allows this Openmp, fopenmp in your when you compile. Yeah, so you don't need to include. So on some newest versions of Mac OS, which are 64-bit only, it turns out this is automatically disabled. So you don't need to do without multilib. It's already automatically disabled by default. But it turns out that this doesn't issue an error, nevertheless. So it's still safe to add it. Now, if it turns out that you might already have GCC installed from some previous installation, because you might install some other software and it turns out that the software installed GCC, then instead of brew install, you will need to issue brew reinstall. Again, this is unlikely because it's unlikely that you used this particular software before, but if you maybe did, then you issue brew reinstall. And so then once this installation is successful or it's finished, then you can check whether you have GCC and Fortran. So both, it turns out that both GCC 10 and Gfortran come installed with this command, brew install GCC. So for example, if I issue GCC -10 -- version, it will tell you that I have it. Okay, and if I do Gfortran -- version, it says GNU Fortran Homebrew and so on, 10.2 version. Okay, so if you use Linux, I'm sure GCC is already installed. Gfortran, I don't know if it is, but it should be easy to install Gfortran on Linux. Pretty straightforward. With your package manager. So once you've done this, we are almost done. This recommended software, GNU Plot, it would be nice to add with Homebrew. So another thing that you might issue here is brew install GNU Plot, and I think in most systems, you need to still use -- with X11. Otherwise, it's not going to work on your Mac. But it turns out that in some newer versions of Mac, you might not need this option, minus with X11. So if this minus with X11 gives you an error, then just remove it. It turns out that in some versions you don't need it. Okay, it's enough to have just brew install gnuplot. And of course, you can also do uninstall, and you can then do install if you have an error. You can always redo your job. Now, this gnuplot is not essential. If you don't succeed to install it, it's going to be okay, but it's useful. So this is gnuplot. Then, yeah, now we go to essentials often. And this you can follow on any platform. It doesn't need to be Mac, but the same on, it's going to be more or less the same on Windows and Linux. So we're going to use Anaconda distribution of Python, Anaconda. Okay, have you heard of this, Anaconda, before? It turns out this is most popular and probably the easiest package manager around for Python. I used many other package managers before for Python, but they're really hard. You need to be a kind of expert to install them. While Anaconda is now so easy, and therefore I decided to use that. Again, it's essential that you install Anaconda after you install Xcode. Without Xcode, Anaconda might not even be able to. You might not be able to install it because Xcode contains this low-level software that Anaconda needs. Okay, so therefore it's a good idea to do it in this order that I've done. Yeah, so you already have probably Python installed on your computer, and you can test before you start doing anything. You can test how good is your current installation of Python. I mean, almost all computers now already have some version of Python, okay? Almost every computer. But the problem is that this installation is probably incomplete in the sense that it's not going to have all scientific packages that we're going to need. And in this case, it might be a good idea to check how good is your current installation, just to make sure that you're not redoing something. Some of you might already use Python before for your scientific projects, and you might already have everything set up, and you don't want to lose that, or you don't want to screw up your current environment. So in this case, you might check your current environment to see if it's okay. Okay. So how do you do that? Well, you execute this command, this command that I wrote here. So you write Python first. So you go into the Python interpreter. Then you write import Skype, and then you just test Skype. So Skype is scientific Python, isn't it? That's the most important part, or the bread of this course. It's at the heart of our course. And if this is properly installed, then you don't need to go through this installation with Anaconda. Okay. Now, of course, my test should be fine because I'm using Anaconda. See, it says at the beginning here that I'm using Anaconda, which is based on CLang. Actually, it's not based on my C++, but it's based on CLang, which is the native C++ compiler on Mac, but that's fine. Yeah, and now it's testing, and eventually it will show how many of those tests were successful and how many of them failed. Now, your installation, if it survives for first 3 minutes or 4 minutes, it's probably okay. It doesn't need to survive all the way to the end, because it turns out that many of those installations, even though are good, they might fail eventually in some high-level software that might be tested here. So if it survives, let's say up to here, you're fine. but most likely your current Python installation doesn't even have SkyPy, and if it has, it might not be successful. So therefore, if this doesn't work, which most likely it's going to happen, we'll break this and we'll go out. Oops. So if this doesn't work, then we have to go through installation of Anaconda. So how do we do that? Well, it's very straightforward. We go to this website, www.anaconda.com, okay, and pretty much follow the instructions. So www.anaconda.com. Then we go to get started, then download Anaconda installers, and then I would select graphical installer, and this could be Windows, Mac, or Linux. Both distributions, all three distributions are available. Okay, so for me, of course, I need Mac OS graphical installer. I click this, download, and then this is a normal Mac package or whatever, Linux package or Windows package, and it's very easy to install. Okay, so that's what you do. Then once you're done with that, so this is installing. So once you're done with that, you should have something which is called Anaconda environment, and I'm just starting that. Anaconda environment, yeah, Anaconda Navigator. Okay, so this is the new application that you're going to get, Anaconda Navigator. You see that? Okay, so now within this navigator, you can see which packages are installed. Okay, there are lots of packages which are already installed, and some of them might not be installed, and you might need to add them. Okay, so I had to add. Well, I added several of them. For example, PyBint 11, I think by default was not installed. No, search packages here. PyBint 11 by default was not installed, but I installed it. You see right now it's selected here, so it means it's installed. When you install Anaconda, it will probably not be installed, and I will show you how to install it in command line. But you can also install it in this navigator if you want to. It's easier to show in lecture notes how to do it in command line. In lecture notes, it's very hard to show how to click, but it's easy to show how to do it in command line. So you will need PyBint 11, and then you will need Numba. For example, Numba is already installed, and what else? Well, this is basically it. PyBint 11 and Numba are the two things that might not be installed. Okay, so everything else is already there. Now, how do you install this extra packages if you want to? Well, here is the instruction. So in command line, you issue this conda install -c conda forge PyBint 11. Now it turns out this conda forge is another distribution or another place, another group of people who are contributing to Python, and they yeah. So basically, you're switching here from the default distribution to the so-called Conda Forge distribution, where the PyBint 11 can be found. So you again, once your Anaconda is properly installed, you can use this command conda, and then you can do install -c conda forge PyBint 11. Okay. I'm not going to do it right now because I already have it, but you will need to do it. So you can also do conda list, and for example, grep PyBint 11, and because mine is installed, it will show me that it exists. Okay. Of course, conda list will show you all the packages that you have installed. Okay, so this is the same listing as what we saw in this graphical environment before. But in command line, it's kind of easier to search. So I'm showing here grep pybint 11, and if this exists, then this particular thing is installed. So once more, pybint 11 is something that is useful for gluing C++ with Python. It's not essential. If you don't do it, you're going to survive the course, but it's useful to have it because then you will see how to add C++ and Python together, how to glue them together. And then the other thing that I would like you to install is Numba. So conda list grep Numba. This might already be installed in some of the distributions. So of course I already have it, but if you don't have it, then you will do conda install Numba. Okay. Now what is Numba? This is we're discussing this install Numba. Numba is a package which is part of the Python development that speeds up the code. So it turns out that they take Python, your normal Python code, and compile it, and they create a kind of compiled version of your Python. And then when you execute it, it's much faster than Python code itself. Okay, so this Numba sometimes works fantastic, sometimes doesn't do anything. On the other hand, it's a really good idea to have it because it takes almost no time to code. All you need to do is just write one single line in front of your function. You add one line that you enable Numba, and Numba will try to speed up your code. Okay. Sometimes very successfully, sometimes less successfully. Okay. But the point is, it's so easy to do it that it really makes sense to have it. Okay. And I think within Anaconda, this Numba should be very, very easy to install, and maybe already installed already for you. Okay, this is it. This is all. So your homework for next time is to install all this software. So what do you think? Doable? How many of you survived?
Yeah, probably, but how can we prove that we install all of stuff successfully?
Okay, so that's the second, that's what I want to discuss now. I mean, we're going to check now there's some code that I uploaded to GitHub. And if you can execute this code, then everything is working. Okay, so should be easy. Should be easy. Yeah. Anybody scared? You're scared.
That's slightly. I have a question actually.
Yeah.
I've been following through this and following through the lecture notes that you had posted online. I see that there's a sequential order to installing this stuff, say Xcode, then Homebrew, Anaconda. I actually have Anaconda from a previous course installed on my Windows machine, but I can't get Xcode. My understanding is I can't get Xcode because I'm on a Windows machine. So how much is that going to affect?
Okay, great question. So if you have your Anaconda already installed, don't touch it. Okay, just keep it. You can add this thing, this Numba in Anaconda or pybint 11 and so on, but don't remove your Anaconda because I don't know what's going to happen. Now, you don't have that's the problem with Windows. I don't know what to do with command line tools. I mean, I explained here how to install this GCC and gfortran. Under Windows, I don't know how to install this. I mean, there were some packages in the past, how are they called? Some command line tools under Windows that can install GCC.
Found some things. Cygwin.
Yeah, Cygwin. Yes, exactly.
Yeah.
Yeah. Cygwin is what was the exactly. Yeah, I used this many years ago, probably 20 years ago. But yeah, this exists now. You see, the problem with Cygwin is the following: you will be able to compile and check GCC. However, I don't know whether you can make Anaconda talk to Cygwin. Okay, how to get these two talking, I have no idea. Now, in order to figure this out, you will need to Google a little bit. I mean, unfortunately, I don't know enough because I don't have Windows. Is there a way to make Anaconda aware of a C++ compiler, such as the Cygwin GCC? Or
Yes, I think you can assign the paths to the Cygwin for the Anaconda.
I see. Okay, that's great. So you can maybe help others if they don't succeed. Yeah. Okay. If this is possible, then maybe you can set it up. So with Cygwin, you can of course install Fortran, gfortran easily. You can install GCC. You can install gnuplot, and you have everything just like on Mac. And then you put a path in Anaconda, and you will be able to do exactly everything that we do on Mac. But I didn't test this, unfortunately, because I don't have Windows computer. So
I'll go ahead and be the guinea pig. Appreciate it.
yeah.
Wait,
So
could you say what you used? What was it? Cygwin?
so Cygwin, yeah. So let me try to find this in the online. Cygwin. Okay, yeah. Let me share the screen again. Let's open this on time. Share screen. Okay. It looks like the Cygwin. Yeah. Large collection of GNU and open source tools which provide functionality similar to the Linux distribution on Windows. Okay, that's what we're looking at, isn't it? So I haven't installed this for many years. So I don't know, but it should be easy. Install Cygwin. You download this thing and install and follow the instructions. And it's kind of virtual environment. Inside Windows, you have all the Linux tools. And basically, that's what we are doing. I mean, all this Homebrew is basically installed just to have Linux type environment on Mac, okay? Because Mac is a sort of Unix, but it's not full-fledged Unix in the sense that it doesn't have multi-core functionality, which is strange. I mean, to me, it looks bizarre that Apple compiler still doesn't have a multi-core instructions available. But yeah, that's what it is. And yeah, unfortunately, the Mac comes with a stripped down version of Python. So in order to use scientific coding or use this for science, we need to have a slightly more complete or more powerful Python. And therefore, we are using this this Anaconda distribution. But yeah, that's it. Any other question?
Professor,
Yes.
I know that we don't have a midterm and final exam, and we have like 7 homeworks, right? And do we have any project or some, like or teamwork to do at the end of the semester?
Well, you can call this homeworks, you can call projects, in the sense that what we're going to do here is I'm going to go through this algorithms and I'm going to sketch them, and I will try to code in real time. In the past, when we were in the classroom, I would code in real time and you would copy things from my coding. I was usually fast, and well, some people were even faster than me, but most of people were slower than me, isn't it? And then your homework is to really make sure that your code works. And if you're not very skilled in coding, this could be seen as a project. Okay, so it wasn't that easy you know, for everybody to finish those assignments, even though we sketch them in the class. Okay, so in the class you will see things working. So in this sense, these are assignments. But I don't want to give you something completely new to develop, because developing a completely brand new algorithm or software might be way beyond what is customary in such a course. This is not a core course. I don't want you to suffer. This course is supposed to help you or prepare you for your PhD work, isn't it? Because I'm pretty sure that most of you who came here need some type of coding, isn't it? At least something to analyze your data, to prepare your presentations, or maybe even to run some codes. And therefore, this is supposed to help you to do this easier, or to learn, update your skills. Okay. Even when I prepare for this course, every year is different. Believe me, I haven't taught it last year because I was on sabbatical, but I was teaching it in 2019, and before in 2019, 2017. Every year, I need to search Google, what's the new stuff, okay? And it's a lot of new stuff, turns out, okay? So every single year, something comes out, and I'm trying to update the course a little bit. I mean, I'm not always doing the latest of the latest, but at least I'm doing something that is, I don't know, a few years old, okay? And the thing which is kind of pretty customary now, or it's most of people seems to be like, is this Jupyter. So we're going to use a lot of Jupyter notebooks. Okay. Now, unfortunately, some of those Jupyter advanced options that I wanted to show, that has to do with manipulating figures. Turns out it's very, very hard to make it work on Mac. Not Matplotlib. Matplotlib is a basic figure preparation. That's straightforward. We're going to do it. But if you want to have, let's say, your photo, okay, from your last vacation, you take your photo from your last vacation and you want to play with it. Okay, you want to do something with it. In Python, that's very easy. However, you have to have something like Is Opencv, which is installed. And now it turns out that this Opencv, at least on my Mac, it was extremely hard to install. I spent 2 days, finally managed to install it, but it was so hard that I don't want to show you how to do it. Okay, I mean, I think that very, very few of us would succeed, and every computer probably needs something extra, and so I can't afford to do that. So in other words, some of the advanced topics I'll not be able to cover because these tools are still kind of in development, hard to install. Okay, but we will cover how to use routines in SciPy, scientific Python, and how to use Matplotlib. And I think that for most of you, when you write your paper or when you want to present your data with Matplotlib, you can show pretty much anything you want. But it's useful to have some skill in Matplotlib, okay? Just to write your paper, you have to have a way of plotting, fast plotting, okay? And analyzing data very quickly. And I think that Jupyter notebooks are great for this. As you will notice, that Jupyter notebooks might not be the best for large-scale coding. And those of you who make large-scale coding will probably realize that it's better to actually save the code in just normal Python file and then execute the Python file. But that's fine. Once you know how to use notebooks, Python files are also easy to produce. So I'm also going to use Python files from time to time, but I'm going to try to update things to Jupyter notebooks. It's kind of, I don't know, maybe it's fashionable, but maybe it's easier to integrate documentation together with code. That's the strength of this, documentation with code. Okay, any other question?
So are these projects are mainly based on the Python or the like the C++ plus the OpenMP or MPI?
90% on Python. So I'm gonna introduce very quickly here in the beginning OpenMP. I'm very most likely I will not even going to talk about MPI, because MPI is something that you use on supercomputers where you have several nodes. Okay, but if you have just your computer, OpenMP can parallelize within the one computer, isn't it? So I'm going to talk about OpenMP because that's something that's definitely useful for everybody. MPI might not be so useful, so that's I'm probably not gonna talk about. Although if you use supercomputers, you need to use that. Now C++, I'm going to use just on few examples to show you how you can achieve, let's say, 100 times faster execution. Okay, because in some cases, C++ might be 100 times faster than Python. Okay, if you have a do loop, isn't it, and you can recode it in C++, you really have huge speed up. And therefore, I want you to be aware of that. Now, if it turns out that you cannot make your computer work with C++, you're not going to fail the course, okay? You're going to still get good grade, but you're not going to be able to use this capability, okay? So if this is not essential for your work, might be okay, okay? But if your work would benefit from knowing how to execute something 100 times faster, then you might try hard to get this working. Okay. As I said, on Mac, this should be completely straightforward following this lecture notes. On Linux, I'm pretty sure that all of you who use Linux are hackers enough that you can translate. The only thing that I don't know how easy it is to do this on Windows, but Cygwin is probably a good workaround, which I didn't test.
Yeah, so can I do the project on the MPI or OpenMP, because I'm from the computer science and just to learn the physics concept behind the simulation codes. So I'm more familiar with the MPI and OpenMP.
Yeah, so I didn't fully understand the question. The point is that how much familiarity with physics you need? Is this the question?
No, I mean, can I do the projects in the C++ and the MPI version?
Sure. I mean,
sure.
Yes. I mean, I'm not going to emphasize this too much. The reason being that some people might not be able to use it. Okay, but sure.
Got it.
Yes. I mean, you can. I'm going to give sometimes a homework that if you have OpenMP, then please implement this with OpenMP enabled, for example, or use it more efficiently or something. So yes, I mean, it's always useful to make things faster, isn't it? So if you can do that, that would be great. But I'm not going to require this from everybody. So if you cannot make it work, it's okay.
Yeah. Professor Holly, I have a question. So when I try to install GCC, it says the without multi-lab is an invalid option. But and then I check my version of GCC. I don't have GCC-10, but I have GCC. Is there a problem with?
You're using Mac. Are you using Mac?
Yes, Mac.
If you're using Mac, then of course you have GCC. Because but this is right GCC -- version or something, and this is going to be Apple GCC -- version, and you will see that this is called Apple CLang. So what I explained before is that this is the Mac, this is the Apple version of GCC, which might be okay, but it will not use. You will not be able to use OpenMP. That's the problem. It does not support OpenMP, unfortunately.
But when I try to brew install GCC without multi-lab, it says like the without multi-lab is invalid option.
Yeah, well, that now requires Googling, unfortunately.
Okay, okay, I
Uh,
see.
So it might be that in this newest version or some version of your software, it will already be OpenMP enabled, and this minus minus without multilib is completely unnecessary. It might be. I don't know. I forgot, because the point is that I installed this like 6-7 months ago, and this without multilib still worked. Okay, but
I see.
this is changing so fast. I mean, every month this community is changing the options, and you can't keep up with this. And I'm not going to reinstall my computer just a day before the class, because the options might change. It's
Yeah, yeah, I see.
so
Thank you.
this is changing too fast for me. I mean, I don't know why particular case without multilib doesn't work. My sincere hope is that even if you don't add this, if it says that minus minus without multilib is not available or it's invalid, then I would Google if they just change this this option to some other option. That's one possibility, or most likely that you don't need it anymore.
Thank you. Thank you.
Possibility, but it's unfortunate then, because it means that my instructions are already old. This 6 months ago that worked. Yeah. Any other question?
Professor.
Yes.
Yeah, so for the part C, you said you will not be covering all topics, you would just do one or two.
Yes.
So I was wondering when we could let you, if you said if there is popular demand for particular courses, for particular topics, you would consider them. So I was wondering when we could let you know. So for instance, I was keen on learning molecular dynamics and perhaps density functional theory, if that was going to be taught.
Yeah. Okay. I mean, density functional theory is something that I might cover if there is enough interest in this group. Might select density functional theory out of those extra topics. Definitely, we cannot cover molecular dynamics and density functional theory. That wouldn't work. And as far as I remember, density functional theory has, molecular dynamics I haven't covered for a really long time. So this is really old type of instructions from probably 10 years ago. But density functional theory is something that I did, that I taught probably maybe 3 or 4 years ago. And that would be easier to kind of make it modern, or making like with this Jupyter notebooks. But that depends on the interest of the rest in the group. So if you all agree that this is an important topic, then I might decide to take this out of the list. Unfortunately, by the time we get through basics of Python and some classical Monte Carlo, it's going to be already hot outside. Okay, so that's how usually it works. I mean, I was very optimistic first few years how much I'm gonna cover, but then I was rushing through and lots of people didn't follow, and then later on I decided that we're gonna go slower, but then we cover much less.
Yeah, it's been hard to find a course on molecular dynamics anywhere in engineering in the past couple of years. Yeah, so I was hopeful.
If you keep your eye out on the chemistry department, Dr. Case in the chemistry department occasionally takes over the computational chemistry course, and a good portion of that course is on molecular dynamics.
Yeah, I mean, actually, he's an expert in that. I'm much more expert in density functional theory and Monte Carlo, so therefore I try to teach this kind of more than the molecular dynamics.
There's some professors in the material science department who work on molecular dynamics too. I think Professor Garofalini does molecular dynamic simulations for class. If you're interested.
But the courses are very rare. I mean, I understand why. They're pretty advanced. And yeah. I see lots of comments here. I didn't follow. Okay. Any other question?
Professor,
Yes.
have you settled on the office hours?
Yeah, just after the class. So,
Okay. So you'll be hanging around today too then?
Yeah.
Excellent.
And then are you gonna upload the recordings on your website?
Well, that's a good question. On my website, I probably will not be able to upload because I don't think that there is enough space in this computer.
Or you could make them a YouTube video and upload the link on there. That's what previous professors did.
YouTube. Okay. I will look into it. Yeah, that might be a good idea. Or Box is another way. I mean, we have at Rutgers, we have Box.
Right.
To do.
You can do it on Canvas. You can just post a link on the Canvas, so that will auto save that in the box.
Yeah, I'm not using Canvas. You're using Canvas for most of other courses or not?
For physics courses, they just use YouTube, but other courses do use Canvas.
Yeah, the CS courses are using Canvas.
Yeah, I mean, Canvas is kind of, my feeling was that Canvas is kind of clumsy.
Yeah, I think YouTube is easier if you're not using Canvas.
Yeah, probably this is better. Yeah. Okay. Any other question?
Professor, so we don't use Canvas, so how could we submit our homeworks?
Homeworks are going to be easy. Just send me an email.
Oh,
because there are very small files. I mean, this Python stuff, it's very small. So you just email. Any other question? Okay, well, thank you very much for coming. We are way past 6:20, isn't it? So if somebody has a question now and would like to stay here, I will keep this link running, but otherwise you're free now to go. And hope to see you next week.
See you next week.
Thank
you, Professor.
Goodbye. Bye. Have a nice time.
Okay. I think I'll have to drop this class, but if you keep the recordings, that'd be really helpful.
Okay, I'll try to.
Thank you so much. Have a nice day.
Bye.
Professor, if I may,
Mm-hmm.
I'm actually in a situation where